Hello everyone, I'm Alessandro and today I'm going to talk to you about Hashi. Hashi is a protocol for cross-chain communication that allows you to send a message using more than one bridge. What? Okay. Okay. Hashi is a protocol that allows you to send a message cross-chain using more than one bridge. Just to give you like a little bit of history that I'm sure you know it. We have seen in the past years that many losses were caused about basically bridges, and users at the moment don't trust bridges anymore because because putting all your trust in a single bridge is very dangerous, since you cannot be sure that that a bridge is free of bugs. Also because building a bridge is very difficult, since a bridge is composed by many components, and be sure that it's completely free of bugs, it's very difficult. Also, if you do a lot of audits, you cannot be sure that basically you don't have bugs. So for this reason, there's need a paradigm shift in the bridge design. So what is Hashi? Hashi is a protocol for cross-chain communication that allows you to send a message cross-chain by using more than one oracles. So the goal of Hashi is to basically distribute the trust among independent oracles, since in this way it will be very difficult to break them all at the same time. So now let's move maybe on the most technical part. How to send a cross-chain message with Hashi. Okay, so the entry point here is the YAO contract on the source chain, which is, let's say, the main contract that allows you to interact with the underlying message relay contract. For each oracle, you need a pair of contracts, a message relay 1 and an adapter. The message relay 1 is the one that is in charge to interact with the underlying bridge contract, while the adapter is a contract that just stores the hash sent from the source chain. Then, when you want to send a message, you have to call the dispatch messages function, the dispatch messages to adapter function inside the YAO by specifying the list of adapters and the list of relayer that you want to use, and obviously the message. Then YAO, for each message relay, will call the underlying message relay by calling the relay messages function. So in this way, each message relay contract must implement the relay messages function. And inside of it, each message relay will call the underlying contract of the bridge. Then, when all bridges will have processed all message independently, you can execute the message. What you need to do is to basically, you have to wait all oracles that will have processed the message. And then you can call the execute messages function on the YARU contract by providing the original message and the list of adapter that you have used. YAO then will just basically calculate the hash of the original message that you passed, and we will compare it with each hash stored in each adapter. If there is consensus, the target contract can be called. Now, guys, I will show you some code that shows this behavior. So, okay, this is just a simple ping-pong contract which has two functions, the ping one and the pong one. The ping one just calls the YAO by specifying, sorry guys, the message relays and the list of adapters. It just encodes, let's say, the function signature to call on the destination chain, which is this one. Then for each adapter, YAO, which is this contract, let me show you. we'll call each message relay. So let me show you our message relay is done, very easy. Let me show you maybe the AMB one. It implements the relay messages function, and inside of it, it just calls the AMB bridge. And this can be done with like many bridges, also with like ZK, like client or ZK bridges. Then, when Yaru will execute the messages here, it will need the original messages, the message IDs and the sender, but these are just needed to calculate the hash, here. It will compare the, wait a second, sorry. It will compare the hash, the hashes, sorry guys, the hashes here. If the hashes are equal, the target contract will be called. In this case, will be the function that will be called will be the Pong1. So the Pong1 will just check that the sender is Yaru, and that the source sender, so the sender that initiated the transaction on the source chain, is actually the other ping pong. And then it will just emit an event. Super simple. Then let me show you, maybe, okay, ping pong. This is on Go Early. Now, let me show you, okay, contract. Okay, now for simplicity, guys, I will just use the one bridge, since on testnet we don't have it many, so I can just use one. But if you like ping, wait a second. I don't want to sell anything. Okay. Okay. Now I'm going to call the ping function. Okay. Okay. Let's wait for the confirmation. It should be like very fast. Okay, you can see within the logs that YAO contract emitted an event which is called message dispatched, which contains the message ID, the data, so the Pong function encoded with the corresponding parameters, and then some events emitted by the message relay. Then on the other side, when you want to execute the message, you need, first of all, be sure that the underlying bridge will have processed the operation. Yeah, it has. Now, within the Yaru contract on the destination chain, you need when you want to execute a message, you need the sender. So, I mean, the ping pong contract on the source chain, the destination chain ID, which is Gnosis, and the data. The data is this one. Okay. I'm sorry. Okay. Message ID is it. You can take it here. It is 5. Sender, okay, okay. Now I will execute the message, wrong network, okay. Okay. Okay, here you can see that the message execution has been completed. Let's wait for the confirmation. Okay, you can see that the Pong event has been emitted. So basically, if we had like used more than one bridge, you had to like wait for all bridges and then call this function by providing the list of all Oracle adapters here. It's really easy. Then I will come back to the slides, just to show you if you wanted to like build a message relay or an adapter. This is the way. Let's say it's super easy. The message relay contract just need to implement the relay messages function, which call again the underlying bridge, and instead the adapter must implement a function called store hashes, which just store for each source ID the message IDs and the message hashes. Now I will leave the talk to my colleague Zen.
Thanks, Ale. Hi, I'm Zeng. So instead of, besides relaying a message using Hashi, we can also like relay the state of a source blockchain to another blockchain using the block header. So it's very similar to relaying the messages. So instead of like relaying, so you can see like the white part is the underlying bridges, and Hashi is just a bunch of like smart contract on top of them. So what you can do is like, for example, I want to relay block 100 from Ethereum to Gnoss Chain, for example. You can call this header reporter contracts on the Ethereum, and you specify which block number you want to call and what is the destination chain you want to pass to. So once the contract function is called, it will store on the destination adapter contracts. And where does the security comes in? So instead of like calling A and B to relay the functions, I can call like connects, wormhole, like for example 5 bridges to relay the same block numbers for me, and they are all passing through the bridges and store in the adapter contracts. So like where Hashi comes in is that you can think of like Hashi like a multi-sig of bridges. So you can define your threshold. For example, I want 5 out of 3 bridges to store the, if I specify the block number and I call 5 bridges to bridge the same block headers for me, and let's say if 3 out of 5 of them store the same hashes, then I can assume that the block header is correct. So that is where the additive security parts comes in. So if you want to interact with Hashi to relay the block headers, it's really that simple. You call the reports headers function on source chain, and then you call the get hash from oracles function from the Hashi contracts. And yeah, so from the source chain, we have this header reporter contracts. As you can see, we specify the block numbers and which adapters we want to use, and also the guess. And once the contract function is called, it will emit this header reported event. So the ID is the block number, and the block hash is the actual block header from the source chain. So after the function is called, it will be stored on the destination chain with hash store events emitted. And yeah, the ID is the block number, and the hashes is the block header. And what you can do with the block hashes is a lot of things. So like you can verify the states from the source chain. And for example, back to the ping pong example that Ale demonstrated, let's say I want to check if an event is emitted from Ethereum, and I want to check on the Gnoss chain. So now we can like have 2 parts to check. First, we can check if the block header that Hashi relays is correct. Is correct. And then we can check the receipt routes and the receipt related data that we fetch from source chain RPC is correct. So let me show you like a simple code. Yeah, so this is the interface of Hashi contracts. So we call this get hashes from oracles with the oracle adapters address. So like for example, I have called 5 bridges to relay the tokens, relay the block headers for me. So here I need to specify all those 5 oracles address here. And domain is the source chain ID. So for Ethereum is 1, Goerli is 5, and the ID is the block number. And what it does is we'll just get all the hashes from these oracles individually. And as you can see, it returns a bunch of an array of hashes. So besides on that, and you can build like your customize what you want to refer from these hashes. For example, if you think like ZK-like client is more reliable, you can just call 5 ZK-like clients and get their block hashes. Or you just want to hash some, for example, I can add some multi-sig wallets, multi-sig oracles. You can just specify your customized logic that you want to check. So yeah, so back to that emit events example. On the destination chain, how do we verify the state and the receipt is correct? So yeah, so in this example, we are going to verify the Merkle proof of the receipt is correct and also the block hash. So first, we define the inputs of the proof. So like here are the receipts related data that you fetch from the source chain. You can just call like get transaction receipts and also get blocks to fetch all this data, and also the log index in the block regarding to the event that you want to prove, and also the block header. This block header is the RLP encoded block header elements like parent hash and state roots and transaction roots. So you can like basically recreate the block hash by hash kcat 2556 hashing this block header. And now we deserialize the data. And now the first thing we have to check is if the block hash that is stored on Hashi adapters are correct. So first we use this block header that we provide. You can fetch it on an RPC on the source chain, and then we call this like reported hash. And then we fetch the hash from Hashi that you call those individuals oracles to pass the block header to. And it's like just return a bunch of block hash. So yeah, we can check that if those 2 block hash are correct, then if it's correct, then we can assume that this block hash indeed is correct. And yeah, and the next logic is just checking the receipts, checking if the emitter address is ping pong or not, and if the topics is the actual ping events topic. And also we can verify the Merkle proof for the receipts. So once it is like verified, you can define your own dApp logic like airdrop or cross-chain governance or just sending a tokens. So yeah, that's a very simple use case for that. And let's say if you want to use Hashi, but your oracles that you want to use doesn't exist yet, you can build your own adapters and header reporters on both chain. So it's very simple, just a few lines of codes. So first on the source chain, we have to like inherit these header storage contracts, and then we store those block hashes. And then here is your oracles or bridge customizing logic to relay the message. For example, CCIP, you can use CCIP send, and other oracles, you can use different methods to pass the message. And also you have to emit the header reported event. And on the destination chain is where the oracles call this adapter contracts store hashes function that will eventually store those block headers on your destination chain. Yeah, so that's a very simple use case of relaying a token. If you have any questions, feel free to check out our docs and GitHub, and also, yeah, Discords. Thank you.